Evening. Is it audible? Hello, good evening. Is it audible? Okay, this is Juhibis from GoSchool Learning Center. We are the fastest growing ETA company in GCC. Our main aim is to provide education to all. So, welcome back to part 3 video of aldehyde ketone and carboxylic acid. In part 2 video, we discussed about the preparation of aldehyde ketone and the physical properties. Today, today I'm going to discuss about the chemical properties of aldehyde ketones. Okay? Okay. So in chemical reactions, we are discussing about the nucleophilic addition reaction and then the reduction and oxidation and finally the reaction due to hydrogen atom. Hydrogen. So tell me what is a nucleophile? What do you mean by a nucleophile? Nucleophile means nucleus loving species. Is it? Nucleophile means nucleus loving species. That is nucleus have positive charge. Is it? Love means the nucleophile should have negative charge. So nucleophile have negative charge. So here nucleophilic addition reaction is occurring. So we are discussing about addition of hydrogen cyanide, hydrogen of sodium, hydrogen sulfate, addition of Grignard reagent, and addition of alcohol and addition of ammonia and its derivative. Okay, so first one is nucleophilic addition reaction. Aldehyde and ketone undergo nucleophilic addition reaction. So in your test, you have to study the mechanism of nucleophilic addition reaction. So we can discuss about the mechanism of nucleophilic addition reaction. So here we are taking a carbonyl compound. That carbonyl compound undergo nucleophilic addition reaction. Suppose a nucleophile is coming and attacking to the carbon. So you know what is a in a carbonyl compound is a polar in nature, is it? So here the carbon is partial negative positive charge and oxygen is partial negative charge. So the nucleophile will always attack nucleophile. The charge of nucleophile is negative. Negative charge it will attach to the positive partial positive carbon, is it? So we will get so you will get the nucleophile attached with to the carbon and this double bond will shift to the oxygen and then you will get a negative charge on oxygen. So this is reversible reaction. This is the step 1. Step 1 is the slow step. Slow step. Then this undergo H plus. This will treated with H plus with a proton. You will get OH. So this is the mechanism of nucleophilic addition reaction. So our next one is reactivity. Aldehydes are more reactive than ketone. Why? This is again an important question. Why aldehyde is more reactive than ketone? The reason is because of two. First one is steric effect and the second one is plus side inductive effect. So we can compare it with, we can take a aldehyde. So this is the general formula of aldehyde and What is the general formula of aldehyde? RC double bond O R. Is it? So this is the general formula of aldehyde, and for this one is for aldehyde and this one is for ketone. Here you can see in carbonyl carbon. Here the carbonyl carbon is attached to one alkyl group. Here the carbonyl carbon is attached to two alkyl group. So in this aldehyde, the nucleophile can easily attack the carbon. But in ketone, it is difficult to attack the nucleophile. Why? Because of two bulky groups is present on aldehyde. So it will hinder the approach of nucleophile. Here only one alkyl group is present and the other side there is hydrogen. So nucleophile can easily attack to the carbon. So the reactivity is more on aldehyde. So that is the first reason because of steric effect. And the second one is because of plus I inductive effect. What do you mean by plus I inductive effect? Here you can see one an aldehyde there is only one alkyl group. So here the alkyl group means an electron releasing group. So it will give electrons to the carbon. Here two alkyl groups, so the electron will release from this side and this side. So the electron will be rich on that. So nucleophile is also negative charge and here more electron is giving. So electron also negative. So the, the reactivity is more on aldehyde than ketone. So why aldehyde is more reactive than ketone? Due to steric effect and plus side inductive effect. I hope this is clear for you. This is an important question that this question may be asked on your board exam. Okay, the next one is, so here now we are discussing about the nucleophilic addition reaction. The first nucleophilic addition reaction is reaction with hydrogen cyanide. Reaction with hydrogen cyanide, that is a carbonyl group. A carbonyl group react with hydrogen cyanide. Hydrogen cyanide. So here, you know, carbon is partial positive charge and oxygen is partial negative charge. Here the Cn minus act as a nucleophile. Cn minus act as a nucleophile and this is get partial positive charge. So again the Cn group will attach to the carbon because opposite charge will attract, is it? So the hydrogen will be attached to this. Here the bond will be break. So you will get COH Cn. And this is called cyanohydrin. Cyano, cyanohydrin. Cyanohydrin. So hydrogen cyanide on reacting with carbonyl compound, you will get cyanohydrin. Is it easy? Okay. The next one is nucleophilic addition of sodium hydrogen sulfate. What's the formula of sodium hydrogen sulfate? Here also we are reacting with carbonyl compound, that is C double bond O plus NaHSO3. What is NaHSO3? This is sodium hydrogen sulfate. So here also the carbon is slight positive charge, oxygen slight negative. Here the HSO3 act as a nucleophile and this will get delta positive charge. So you will get, what is the product? Again attach the SO3, SO3H is the nucleophile, so it will come as OSO2H and then ONA. So in this proton transfer will occur. Proton transfer will occur. So this hydrogen will be shifted to oxygen and this Na will be attached to the OSO2 Na. So you will get an addition product. So here we are discussing about addition product. We are adding this sodium hydrogen sulfate to aldehyde and ketone. So it will become OH and this is SOO2Na. Is it clear? So you have to identify which is the nucleophile. In this sodium hydrogen sulfate, SO3H is the nucleophile. That nucleophile will attack on the carbonyl carbon and the Na will be attached to the oxygen cell. Then proton transfer will occur. Then we will get the product. Okay. The next one is addition of Grignard reagent. Then tell me what is the formula of Grignard reagent? We already discussed about Grignard reagent. Grignard reagent, the formula of Grignard reagent is R RMGX. Is it? The formula of Grignard reagent is RMGX. So here, if a formaldehyde is reacting with Grignard reagent, you will get primary alcohol. Other aldehyde react with Grignard reagent, you will get secondary alcohol, and ketone is reacting, you will get tertiary alcohol. Is that clear? So first we are reacting with formaldehyde. The formula of formaldehyde is HC double bond OH. This on reacting with Grignard reagent, that is RMGX. RMGX. This alkyl, here the alkyl part is negative nucleophile and this MgX will be positive. So this alkyl group will attach to this carbon and this OMgX will be attached to O. Then you will get an intermediate, that is HCr and OMgX. This on hydrolysis, you will get alcohol. This on hydrolysis you will get alcohol. Here are one hydrogen here and OH here. So this will eliminated as MgOHX and you will get primary alcohol, that is HCOHR plus MgOHX. So what is this? This is primary alcohol. Okay. I hope this is clear for you. So next we are treating Grignard reagent with other aldehyde. That is, if I am taking ethanol, that is CH3 C double bond OH plus treating with Grignard reagent, that is RMGX, you will get this alkyl part will attach to the carbon and this MgX will be attached to O. You will get CH3 C R and OMG. This MgX will be attached to the oxygen OMgX. Then you will get H. Again, we are hydrolyzing this. We are hydrolyzing this we will get, that is CH3 OH R. So what is this? This is secondary alcohol. Is it clear? So next we are treating it with ketone. Next, ketone is reacting with Grignard reagent. What do you get? So the formula ketone is RC double bond O R R. Is it? Sorry. R plus RMGX. So here it is negative and this one is positive. So the alkyl group will attach to the carbon and this bond will shift to this and this MgX will be attached to the oxygen. You will get RCO MgX R R. Again, on hydrolysis, you will get corresponding alcohol RC R OH R. So what is this? Say tertiary alcohol. So addition of Grignard reagent we get, if you are treating formaldehyde with Grignard reagent, you will get primary alcohol. If you are treating other aldehyde with Grignard reagent, you will get secondary. And if you are treating ketone, you will get tertiary alcohol. Okay. Then can you tell me the product of this compound? That is CH3 C double bond O CH3. It is treating with Grignard reagent, that is methyl magnesium bromide. Then tell me the product A, and this A will be on hydrolysis. You will get a product B. What will be the product? So this is here the alkyl part will go to the carbon and this MgBr will be attached to the oxygen. Then you will get product A. Is it? That is CH3 COMgBr CH3 CH3. Is it? You get the product A. Then this product on hydrolysis, that is H3O plus. On hydrolysis, you will get tertiary alcohol. Is it? Here add hydrogen, one hydrogen here and OH. This will eliminate as MgOHBr. So you will get tertiary alcohol. MgOHBr. Is it clear? So first we discuss about addition of hydrogen cyanide. Then we discuss about addition of sodium hydrogen sulfate. And the third one is addition with Grignard reagent. Okay. The next one is addition of alcohol. So here we are treating aldehyde. Aldehyde is reacting with one equivalent monohydric alcohol. So here first we are reacting aldehyde, that is RCH double bond OH with an alcohol, that is ORH in presence of dry HCl, in presence of dry HCl. Here this RO dash, Here R or R dash is act as a nucleophile that will attach to the, so this is negative and this is positive. Here you know carbonyl carbon is positive and this one is negative. Is it? So the RO group will be attached to the carbon and this hydrogen will be attached to the oxygen. So you will get R C H O H O R dash. So this is called hemiacetal. Hemiacetal. So first we are adding this group to the aldehyde. On the second step, in the second step we are again adding one molecule of alcohol. Here elimination of water molecule is occurring. So here this OH and this H will be eliminated and this OR dash will be attached. That is RCH OR dash OR dash. So what is this? This group is called acetal. Acetal. So that is written here. Aldehyde react with one equivalent of monohydric alcohol in presence of dry hydrogen chloride, dry HCl. You will get alkoxy alcohol. That alkoxy alcohol intermediate is called hemiacetal. Then we are treating it further with one more of molecule of alcohol to give gem dialkoxy. Gem dialkoxy means there are two alkoxy groups on the same side. So it is called gem dialkoxy compound. That compound is called acetal. That compound is called acetal. Okay. Next one is addition of ammonia. Addition of ammonia and its derivative. Then tell me what is ammonia? What is the formula of ammonia? So the formula of ammonia is NH3. Is it? The formula of ammonia is NH3. So here I am writing this ammonia as NH2, NH2H, NH2H. Instead of H, it may be alkyl group, aryl group, any group can be come. So we are given it as, instead of this, we are giving this as Z. So Z may be an alkyl group or aryl group. Alkyl, aryl or amine, NH2, NH2, etc. So first we are treating the carbonyl compound. So carbonyl compound reacting with ammonia, that is NH2H. Just eliminate the water molecule. Just eliminate the water molecule. Then you will get the product as C double bond N H. Email. So next one is, this is the first reaction with ammonia. So here elimination reaction is occurring. So here in all the cases water molecule will be eliminated and write the product as it is. Just eliminate the water molecule and then you will get the product C double bond N H. That is Amy. The second one is, if we are treating with carbon compound is treated with an amide NH2R. Again, just eliminate the water molecule. Just eliminate the water molecule. Then you will get the product as C double bond N R plus H2O. So this is called ship base. Ship ship's base. So carbonyl compound on reacting with amine, you will get ship's base. What you have to study, that you have to learn the reagent. You know that the water molecules is eliminating in this reaction. So you have to learn the formula of the reagent. Next we are treating it with hydroxylamine. Carbonyl compound is reacting with third one is this carbonyl compound on reacting with hydroxylamine. Then what is the formula of hydroxylamine? You know the formula of amine, that is NH2. Hydroxy group, which is hydroxy group OH. So NH2OH is the hydroxyl group. So here also just eliminate the water molecule. Then you will get C double bond N OH. That is oxide. And the fourth one is carbonyl compound. Carbonyl compound on treating with hydrazine. What is the formula of hydrazine? Hydrazine, that is NH2. NH2 is hydrazine. Eliminate the water molecule. Then you will get C double bond N NH2. So you will, this is hydrazine. This is hydrazine. This hydrazine on reacting with carbonyl compound, you will get corresponding hydrazone. So this is hydrazone. Okay. The fifth one is, if the carbonyl compound is reacting with semi-carbazine, that is NH2 NHCO NH. Again, eliminate the water molecule. This is semi-carbazine. On reacting, you will get semi-carbazone. NH, So this is semi-carbazone. So you have to learn the formula of this reagent. What is hydrazine? NH2 is hydrazine. What is semi-carbazine? NH2 NHCO is semi-carbazone. So the next one is, if we are treating if we are treating with phenylhydrazine. What is phenylhydrazine? You know the formula of hydrazine, that is NH2. Phenyl group, there is a benzene ring, is it? So the next one is C double bond O on treating with hydrazine, phenylhydrazine, that is NH2N NH, treating with benzene. Then you will get, eliminate the water molecule. Eliminate the water molecule and then you will get C double bond N NH NH. So what is this? So this is phenyl hydrazine. Is it? This is phenyl hydrazine. Then it is if we are treating carbonyl compound with hydrazine, we will get the product hydrazone. So it is phenyl hydrazine. So we will obtain phenyl hydrazone. We will get phenyl hydrazone. Next, if we are treating carbonyl compound with 2,4-dinitrophenyl hydrazine. So now you learn the formula of phenyl hydrazine. So 2,4-dinitro, that means in 2,4 position there is a nitro group. So we can write the formula, that is C double bond O plus NH2 NH, then the phenyl group on that 2,4 position there is nitro group. So this is 2,4-dinitro dinitrophenyl hydrazine. On reacting, eliminate the water molecule. Then you will get the product C double bond N, C double bond N, NH, then you will get the product. I'll draw here. You will get the product 2,4-dinitrophenyl hydrazone will be obtained. NH, NH, then the phenyl group, then on 2,4 position there is NO2. So this is 2,4-dinitrophenyl hydrazone. So this is all about the reaction with ammonia and its derivative. First we discuss on first we are discussing about carbonyl compound reacting with ammonia. You will get amine. And on second, the carbonyl compound on reacting with primary amine. You will get shift base. And the next one is the carbonyl compound on reacting with hydroxylamine. You will get oxime. Then on carbonyl compound on reacting with hydrazine, you will get hydrazone. And you on carbonyl compound on reacting with semi-carbazine, you will get carbazone. Is it easy? Just eliminate the water molecule. You have to learn the reagent formula. And what you get? You have to learn the product name also. Okay. The next one is reduction. In reduction, there are two methods: reduction to alcohol and reduction to hydrocarbon. In reduction to hydrocarbon is again two, again classified into two, that is first one is Clemmensen reduction and the second one is Wolff-Kishner reduction. So the Clemmensen reduction, and this is very important. Okay, this is named reaction. The first one is Clemmensen reduction and the second one is Wolff-Kishner reduction. The in reduction to alcohol, we are aldehyde or ketone reacting with oxidizing or aldehyde and ketone reacting with reducing agent like sodium borohydrate, lithium aluminum hydrate, or we can done catalytic hydrogenation. Catalytic hydrogenation means what? Addition of hydrogen in presence of a catalyst. Here, this is CH3CHO. The CH3CHO on catalytic hydrogenation, that is addition of hydrogen in presence of a catalyst, you will get primary alcohol, that is CH3, CH3, CH2, OH. You will get primary alcohol. I'll give another example, that is CH3, CH2, COH. COH. Write the product. Write the product. Write the product. So here, this pi bond will break. One hydrogen will be added here and one hydrogen will be added here. Then you will get corresponding alcohol. You will get corresponding primary alcohol. That is CH3, CH2, CH2, OH. That is, you get propanol. You will get propanol. Suppose if you are taking RC double bond O R, RC double bond R, on treating with sodium borohydrate NaBH4, then you will get RCHOH, or you will get secondary alcohol. So I hope it is clear for you. Next we are discussing about reduction to hydrocarbon. So this is an important reaction, that is the name reaction is Clemmensen reduction. First one is Clemmensen reduction and the second one is Wolff-Kishner reduction. Here the carbonyl compound is converted to hydrocarbon, that is CH2 group. The CO group will be changed to CH2 group in presence of zinc amalgam and concentrated HCl. The carbonyl group of aldehyde and ketones reduced to CH2 group in presence of zinc amalgam and concentrated HCl. You will get hydrocarbon. That reduction is called Clemmensen reduction. That is carbonyl compound, that is C double bond O, on treating with zinc amalgam is an HCl and concentrated HCl. This CO group will be changed to CH2 group, that is methylene group plus H2O. So in your exam, they will give a carbonyl compound CH2 C double bond O H. And this group will change to CCH3, C double bond O, CH3. In presence of zinc, amalgam, and concentrated HCl, write the product. What is the product? What is the product? So this group will change to CH2 group. So you will get CH3, CH2, CH2, CH3. What is this? This is hydrocarbon. You get butane. There is 4 carbon atoms, so it is butane. Okay. So you have to learn the reagent. So we have two methods for the reduction to hydrocarbon. First one is Clemmensen reduction. Clemmensen reduction is only occur in presence of HCl. Clemmensen reduction only occur in presence of concentrated acid. So remember that. And the next one is Wolff-Kishner reduction. So here also the carbonyl compound on first reacting with hydrazine. Then what's the formula of hydrazine? NH2NH2. So what will happen when a carbonyl compound react with hydrazine? First it will eliminate the water molecule. Is it? Then this hydrazine we will get hydrazone. Carbonyl compound react with hydrazine, we will get hydrazone. This hydrazone on reacting with NaOH or KOH in ethylene glycol on boiling, we will get corresponding hydrocarbon. Okay, here the carbonyl group can also be reduced to methylene by treating with hydrazine. By treating it with hydrazine, followed by heating with sodium or potassium hydroxide in ethylene glycol. So here we are using base. On Clemmensen reduction, we are using acid. So the reaction will be carbonyl compound that is C double bond O reacting with hydrazine NH2, NH2, water molecule will be eliminated, that is H2O. Is it? Then you will get hydrazone NH2. Is it? Then this on reacting with NaOH or KOH in ethylene glycol on boiling, we will get corresponding hydrocarbon plus N2. N2 will be eliminated. So first the carbonyl compound on reacting with hydrazine, the water molecule will be eliminated and you will get hydrazone. That hydrazone on reacting with NaOH or KOH, ethylene glycol, we will get hydrocarbon. So tell me the product of this compound CH3, CH3, C double bond O, CH3 on reacting with hydrazine, then on KOH in ethylene glycol, write the product. What is the product? Simple. It's it. Here this group will change to CH2. Is it? So the product will be CH3, CH2, CH3 plus N2. So This is about the reduction. First we discussed about the reduction of alcohols, and then we discussed about the reduction to hydrocarbon. In reduction to hydrocarbon, they are of two type. First one is Clemmensen reduction. In Clemmensen reduction, we are using carbonyl compound is reacting with zinc amalgam and concentrated HCl. The reaction is always occur in acidic medium. And Wolff-Fishner reduction is we are using hydrazine, and that is treated with KOH in presence of ethylene glycol. You will get hydrocarbon. The third one is oxidation. Aldehyde are oxidized to aldehyde. On oxidation, you will get carboxylic acid, that is RCHO. On oxidation, you will get carboxylic acid, RCOH. Aldehyde, on oxidation, you will get carboxylic acid. So, which are the strong oxidizing agent? Which are the strong oxidizing agent? KMNO4, potassium dichromate, K, Cr3, CrO3 plus H2SO4. These all are strong oxidizing agents that can convert aldehyde to carboxylic acid. Then the mild oxidizing agent. You have to learn which are the strong oxidizing agent and which are the mild oxidizing agent. So here the mild oxidizing agent like tolerance reagent and Fehling's reagent. So aldehyde can be oxidized to carboxylic acid. Okay, then what is tolerance reagent? What is tolerance reagent? Ammoniacal silver nitrate solution is tolerance reagent. Why we are using tolerance? Actually, these tolerance reagent and Fehling's reagent we are using this as a distinguishing test for aldehyde and ketones. In tolerance reagent is what? You have to learn this, okay? Ammoniacal silver nitrate solution is called tolerance reagent. What is tolerance reagent? Ammoniacal silver nitrate solution. Here, I don't know. I have two test tube. And two test tube. A compound A is there and compound B is there. I don't know which test tube containing aldehyde or ketone. So I am adding ammoniacal silver nitrate solution reagent to test tube A and test tube B. And after some time, I can see that a bright silver mirror is obtained in one test tube. So from that, I can understand that that test tube contains aldehyde. So this is actually a distinguishing test for aldehyde and ketone. So aldehydes give the answer and ketones doesn't respond to this reaction. So here tolerance reagent is ammoniacal silver nitrate solution. On warming aldehyde with freshly prepared silver ammoniacal silver nitrate solution, that is tolerance reagent, we will get a bright silver mirror. We will get a bright silver mirror produced, and that is due to the formation of silver metal. Silver metal. And the aldehyde are oxidized to corresponding carboxylate ion. Aldehydes are oxidized to corresponding carboxylate ion. So RCHO, aldehyde reacting with tolerance reagent, that is AgHNO3 twice, AgHNO3 twice, we will get the aldehyde is oxidized to carboxylate anion, that is RCHO. RCHO. R RCHO is oxidized to RCOO minus. Here the silver undergoes self reduction and to form Ag. Plus, then you will get ammonia plus. So aldehyde reacting with aldehyde react with tolerance reagent. You will get carboxylate anion. You will get silver metal. The bright silver mirror is obtained, and you can see on the test tube that, and you can distinguish that compound containing aldehyde ketone doesn't respond to this reaction. So this reaction also respond to aromatic aldehyde. It only doesn't give respond to ketone. The next one is Felling's test. What is Felling's test? So in Felling's reagent, there are two types of solution: Felling solution A and Felling solution B. Felling solution A is aqueous copper sulfate, and Felling solution B is called alkaline sodium potassium tartrate. On we are taking equal amount of A and B, and we are mixing it equally, and we will get Felling solution. And we are here also we are taking two test tube, one test tube A and test tube B. Here also we are adding Felling solution to both the test tube. So you will get a orange precipitate, reddish brown precipitate will be obtained, that compound containing aldehyde. So Felling's test means that a mixture of two solution, that is Felling solution A and Felling solution B. Felling solution A is aqueous copper sulfate, and Felling solution B is alkaline sodium potassium tartrate. So then we are mixing it with on heating the Felling test aldehyde. The Felling's reagent give a reddish brown precipitate of cuprous cuprous oxide is, okay, cuprous oxide it is, Cu2O. You will get a precipitate of Cu2O, and here also the aldehyde is oxidized to corresponding anion. And this one is important here: aldehyde, aromatic aldehyde does not respond this test. Failing solution, in failing solution, aromatic aldehyde does not respond. Okay. So the reaction will be, here it is. I will write here RCHO on reacting with Cu2 plus 5 in presence of a base. So here both the reactions are carried out in presence of a base. Okay, you will get corresponding carboxylate anion, that is RCO minus, plus you will get CuO plus H2O. So this is red brown precipitate. So you can find on the test tube a red brown precipitate. So this is all about oxidation. Oxidation, the aldehyde can be oxidized to carboxylic acid, Here ketones cannot be oxidized by mild oxidizing agent. We can oxidate it. The ketone can only oxidize with vigorous conditions. So ketone does not give answer to this tolerance reagent and fillings reagent. Then we discuss the distinguishing test for aldehyde and ketone. First one is tolerance reagent. What is tolerance reagent? Ammoniacal silver nitrate solution is tolerance reagent. And on reacting with aldehyde tolerance reagent, we will get a bright silver mirror. From that, we can understand that the compound containing aldehyde. Second one is filling solution. The filling solution containing two types, filling solution A and filling solution B. Filling solution A is aqueous copper sulfate and filling solution B is sodium potassium tartrate. And here we will obtain a red brown precipitate of Cu2O. So this is asking in JEE NEET exam, what is the red brown precipitate obtained on reacting with aldehyde? On reacting aldehyde with filling solution, what is the red brown precipitate obtained? That is Cu2O. Okay. The next one is oxidation of methyl ketone, or you can say halopho. What is halopho? So here the methyl group, that is CH3 C double bond O, or CH3 CHOH group only give this reaction, halophone reaction. So in this reaction, the compound is reacting with sodium hypohalate. What is sodium hypohalate? What is the formula of sodium hypohalate? That is NaOH. This is sodium hypohalate. So R C double bond O CH3. This compound containing COCH3. You have to look at the compound, whether the compound containing C double bond or CH3 group. Only C double bond CH3 group or CH3 CHOH group will answer for haloform reaction. Here this CH3 group will change and you will get haloform. That is, you are treating with the ketone or aldehyde with sodium hypohalate, that is NaOX, and you will get RC double bond O. RC double bond O, ONA, ONA plus CH3, CH3X3. This is called haloform reaction. Haloform reaction. There is no change on the double bond here. Another example for this reaction is, that is CHCH3 double bond CH3 double bond O CH. So here also there is COCH3 group is there. This will change to, this will react with NaOX, that is sodium hypohalate. You will get CH. There is no change on the double bond here. Only change will occur on the CH3 group, that is on this group. This group will change to CH3, CH3, This group will change to ONA plus CH. So this is haloform reaction, oxidation of methyl group to haloform reaction we can convert it. So here only iodoform reaction will give color. Yellow precipitate will be obtained. So if we are taking here, that is R C double bond O CH3 is treating with NaOH, NaOI. So this group will change to RC double bond O ONA plus CHI3. This will form iodoform reaction, and it will give yellow precipitate. Iodoform reaction, and it will give yellow precipitate. So I hope this is clear for you. We are discussed here now the chemical reactions of aldehyde ketone. The first one is uh, nucleophilic addition reaction, then reduction, and then oxidation. There's one more, the reaction to alpha hydrogen, that we'll discuss on next class. On Monday, I am coming on live, so stay tuned with us.